Okay, guys, so our first review video here for today is going to be on product and quotient rule. So this video in particular is just going to focus on product rule. And so I'll leave the essential question here. You can read it at your own pace. Your exit ticket today is going to be something that you upload to Google Form, and you'll be able to find that on Classroom. So the intent of this video on product rule is to give you something and do an example with you that's probably slightly more complex than what you would see on your practice problems. Because just for the more basic stuff, I'm hoping that you can use your notes, you can use each other's notes that you uploaded to Classroom yesterday, hopefully, and just use that. But the purpose of this video is just, again, just something a little bit more complicated in case you need help as you're working through some of your practice problems, okay? So let's start by reminding ourselves what the product rule for derivatives actually is. So one quick way that I always used to write it on the board first try was f prime times g plus f times g prime. And that's the formula for taking the derivatives when you're multiplying two expressions together. So I'm just going to leave this up here so we can always kind of look to that. Okay, so the example I'm going to do for product rule is going to be one that involves a radical. I'm going to say take the derivative of f of x equals the third root of x times x squared plus 8. Okay, and we want to find f prime, or the derivative of this. Okay, this is obviously something we can use product rule with because we're multiplying two different expressions together. Something that we always talked about in first try was that when you have radicals, it's always pretty helpful to turn them into, if we can see that, turn them into exponents. So I'm going to say third root of x is the same as x to the 1/3, and I'm going to leave x squared plus 8 in parentheses. Okay. Also, another basic rule, I don't know if I need to mention this or not, was the power rule. For derivatives. When you have something raised to a power, the derivative of that is just bring the power or the exponent out front, keeping your expression or your variable, and subtracting 1 from the original exponent. Okay, so that was the power rule. So this power rule should hopefully help us because we have a couple exponents here. So let's take the derivative of this. I'm going to say f prime, our derivative, is the same thing as, so let's label this our f, let's label this our g, okay? So f prime times g plus f times g prime, so let's do f prime. So it's going to be 1/3 x. 1/3 minus 1 is going to be negative 2/3, okay? So that's f prime times g is going to be x squared plus 8. Okay, so again, this is f prime times g plus, now we're going to do f times g prime. Okay, so f is still x to the 1/3. G prime is now the derivative of this piece. Okay, so the derivative of that is going to be 2x. Remember, constants go away when you're taking derivative, it's just 0. So it's just 2x on the inside. Okay, so usually taking the derivatives kind of the quick part. The hard part, or the challenging part, is always the algebra, because we always have to simplify, combine like terms, work with fractions. So this is where it gets a little tough. So I'm multiplying two expressions here, so I can distribute this, right? Okay, so let's try to simplify this a little bit. 1/3 times 1 is 1/3. X to the, all right, so we have a negative 2/3 and a 2. Remember that when you're multiplying with exponents, you actually add the exponents together. So negative 2/3 plus 2 comes out to 4/3. And if you don't believe me, you can just go off to the side on your own and say negative 2/3 plus 2/1. Once you actually find common denominators and add them together, you get 4/3. Okay, plus I still have to distribute it to the next one, so that's going to be 8/3 x to the negative 2/3. Okay, plus 2 times 1 is 2, x to the, let's see, if this is a 1, 1/3 plus 1, again, if we add those together, common denominator is going to come out to 4/3. And if you want to check that, you can write off to the side on your own. 1/3 plus 3/3 comes out to 4/3. Okay. Normally we would check here to see if we're done. We're still not. Is there anything else we can simplify? It looks like there is. We've got common terms here, same exponents, so we can combine those. Okay, so if you were to add 1/3 plus 2, you come up with 7/3. X to the 4/3, because that's our common exponent. Okay, we're just combining like terms here. Plus 8. Let's do this. Let's take our negative exponent and place it down where it's supposed to be. So let's take that negative exponent and place it in the denominator, okay? And actually, it might make more sense if I do this. Let's keep our numerators and denominators separate. So this is going to be, let's see, what was this? X to the 4/3. Okay. All right, the reason I wrote it like that is because, again, we're not quite done yet. If there's any way that we can factor, combine like terms, find common denominators, we have to do that. That's called simplifying, okay? So obviously here we've got two fractions that we're adding. We can add these together. We just have to find common denominators. These both have a 3, so we're good there, but this one's missing an x to the 2/3. So if I multiply this by x to the 2/3 to get my denominators to be the same, I have to multiply the top by x to the 2/3. Okay? So what that does for me is, let me just slide this up a little bit. So this is going to be 7x. Now I've got 2/3 plus 4/3. Okay, 2/3 plus 4/3, when you add it together, is 6/3. And when you simplify that, it just comes out to 2. Okay, plus 8. 8's not going anywhere. And now we've got 3x to the 2/3 in the denominator. Okay. There is nothing I can factor out here in the numerator. There's no like terms I can combine. This is as simple as far as we can go. So I'm going to say the derivative of our original function is this. Okay. All right. So that's our one example with the product rule. For an example with quotient rule, just jump to the next video.